Welcome to Kojo's Math. Let me pull this up. And today we're talking about, well, Kojo's Pre-Algebra, we're talking about the triangle inequality. Now the triangle inequality works for every single triangle. Right triangles, obtuse, acute, every single triangle you can think of. And what it is it says, here's the rule. The sum of the lengths of any two sides of a triangle is greater than the third side. That means if I add up any two of these sides, I add them together, the sum of those two sides together should always be greater than the other side. So if I add E and D, it should be greater than F. F and D should be greater than E. And then E and F should be the last one. So I can't remember which two letters I said already, so give me a break. So here it is. D plus E is greater than F. If I add sides D plus F, they're going to be greater than E. And if I add sides E plus F, they're greater than D. Now notice, we used the letters D, E, F. We did not use the letters A, B, C. Do you know why? I hope you said because of the Pythagorean theorem. If you see the letters A, B, C, you should immediately think about the Pythagorean theorem and wonder if this is a right triangle. The Pythagorean theorem is only associated with a right triangle, A, B, C. Those are the two legs and the hypotenuse. The triangle inequality is associated with every triangle, and that's why they named those sides D, E, F. So given that rule, that allows us to be given any three measurements and determine if they are a triangle, because adding any combination of these three numbers should always yield, adding any two will always give you a greater amount than the third side. Well, let's try it. If I add 10 plus 71, I get 81, and is 81 greater than 50? Sure. 70 plus 50 is 121, and 121 is greater than 10. Yeah, but the third side, 10 plus 50 is 60, and 60 is not greater than 71. So this is not a triangle. When I come down here, if I add 60 plus 82, I get 142 is greater than 100. And then if I add 60 plus 100, I get 160 is greater than 82. And if I add 100 plus 82, it's greater than 60. So that's a triangle. That's a yes. We come down here and we say, okay, I'm going to add 53 and 138. Well, obviously, if I add 53 and 138, that's going to be greater than 85 because 138 already is. So that's the side, that definitely meets the conditions. But then if I add 53 plus 85, I get 138. Well, this is 138 equals 138. And the triangle inequality did not say that it could be greater than and equal to, or equal to. It has to be greater than. So therefore, this would be a no because it doesn't meet all the conditions. All the combination of any of the three sides, any two of them must always be greater than the third side. You can't have two yes and one no. Well, let's look at this word problem, because this is how you use the triangle inequality. A courier has to make deliveries to two businesses. The businesses are 4 miles and 9 miles from the courier's office. The three locations do not lie in a straight line. So because they do not lie in a straight line, then you know they have to be a triangle. You got to understand that. That's that abstract thought. If they're not in a straight line, they have to be in a triangle with those three distances, right? Because there's three locations we're going to go in between. Without any other information, what can you say about the distance between the two businesses? Well, let's make a rough sketch of what we know. We know that the courier's office is 4 miles from business 1. So I'll say B sub 1 for business. That's a way to organize my data. I know that it's 9 miles to another business, B sub 2. And I want to know the distance between these two. Well, the first thing I'm going to do is I'm going to remember the triangle inequality. I'm going to use what I know. So I'm going to say 9 plus 4 has to be greater than the question mark. 9 plus 4 has to be greater than this because when I add two sides, they have to be greater than the third side. So I get 13 is greater, and we'll plug in an x there. Now, this can't be 13. So it's any number up to, not including 13. So it could be a decimal, it could be a fraction of a mile, but it can't be 13. So we're going to write x is less than 13. It has to be less than 13. So how do we find this other side? Because it says it could be less than 13. Well, let's plug a number in like 2. Because it said x is less than 13. So if I put a 2 over here, 2 plus 9 is 11, and 11 is certainly greater than 4. That works. But 4 plus 2 is 6. 6 is not greater than 9, so that won't work. So what are we going to do to figure out the two numbers that determine how far apart the distances can be apart and still be in a triangle? So what we're going to do, instead of adding the two numbers, we're going to subtract them. So we get 9 minus 4. Now when we subtract them, it's not going to be that this x has to be less than 5. Think about it. Because we just proved that if we plugged in a 2, which is less than 5, because 9 minus 4 is 5, how do you determine what sign goes here? It's not less than 5 because we proved that 2 doesn't work. Or let me put it this way like we did up here. 13 down, so we'll put the 5. So how do we put, what sign do we put there? Well, 5, x has to be greater than 5. So this number has to be less than. So when you subtract, it has to be less than the number you're looking for. When you add, it has to be greater than the value. And when you subtract, it has to be less than. Because now, x is greater than 5. Because if I plug the 5 in there, 5 plus 4 is 9, and 9 equals 9. That's not a triangle. If I had said that x could be less than 5, then it would fit this. X is less than 13. And we proved that x, when it was 2, doesn't work. So what's the range of the distance that it could be? Well, it's between 5 and 13 miles. So if I put this on a number line, let's put this so we can identify it, and I had 5 and 13, the circles would be open because it's not inclusive of 5 and 13 because it's not equal to, and it would be any number, any real number between 5 and 13. Between. Now, you have to rewrite this into a compound inequality. A compound inequality is where you don't have to say x is less than 13 miles and x is greater than 5 miles. You write x in the middle, and you write x is less than 13, and x is greater than 5. That would be your answer. That's called a compound inequality. 5 is less than x is less than 13. That's defining your range of numbers between 5 and 13, and any of those numbers could be the distance of the two businesses. We don't know. We only can come up with the range of numbers of the distances it could be. So now what I want you to do is I want you to pause the video, and I want you to answer this question. I want you to jot down the two main differences of how is the triangle inequality different from the Pythagorean theorem. Pause the video and then turn it back on when you're ready. Okay, let's see how you did. First of all, the Pythagorean theorem is associated only with right triangles. And the triangle inequality is associated with all triangles. That's a major difference. And the second main difference between the two, the Pythagorean theorem and the triangle inequality, is the Pythagorean theorem, you find either the exact answer, I mean you round it if it, sometimes, but you get an actual measurement for one of the legs or the hypotenuse. You will get a number. And in the triangle inequality, you will get a range of numbers. You will never get an exact answer. You will have to have a range of numbers that says you have a minimum and a maximum, and anywhere in between it could be. So, you don't need to write down anything you've learned. If you have any questions, write them down. We'll go over them in our class the next time we have class. And start your homework that's assigned. And have a great day. And I need to turn my camera off, and I'll see you